Hello everyone, my name is Mingyuan Ma. I'm the sophomore at Berkeley and studying the statistics, and I'm here to demonstrate my Project0 Goldpoint for 61B, CS61B for 2020. And forgive me that I cannot really clearly explain the whole stuff in English because I'm not really good at English speaking, but I will try my best to help you guys to understand my presentation as clear as possible. So I'm now going to share my screen. Okay. And before my presentation, I need to correct it or do the citation for the data that I use for the Project0 Goldpoint. The data that I mainly use is from this file, the Sparrow. I use mainly on this data, and this is my data, and I just use the data from the Sparrow.txt this file, and mine is m1y.txt file, and I just changed a little bit. I just did really tiny changes. I changed the number of planets from 17 to 12, and I changed the graph of the stars, all of them to the sun, because in my demo there will be different stages based on the times of eclipse, but their initial graph, their initial stage is sun. And what I did, so I will type something that what I did if I didn't forget too much of them. The first change, you can call, yeah, the first change, the first thing, the first change I did is to count the times of collision. And the second things I need to do, and how to do this, I will not say too much about the code, but how to do. So so how to count the times of collision, you need to define a public property or characteristic, public method, yeah, public method to do as a counter. And based on the times of collision, you can find, you will change into different stages. And different stages means the automatic give automatic change of the graph. I don't know how to say this. The automatic change of the graph. And finally, because I'm not a astrophysics major, so I cannot do too much calculation on this kinetic gravitational force and the energy, and also including the momentum, and also the angle momentum and normal momentum, kinetic momentum. So I cannot do too much calculation on that. So I didn't change a lot of the data. I didn't change the velocity. The only change on the stages is the velocity of the Kevin. The Kevin is the man that will be appearing in the final stage. And the Kevin has the final stage has the velocity equal to 0, both on the velocity x equal to velocity of y equal to 0. And yeah, that's it. And how to count the times of collision is the key point of my projects, of my innovation. And I will not say too much about that. And how to automatic change of the graph is also, it's not as hard as the times of collision, but you just need to do something. Yeah, but I will not say too much about my code. And the challenges, challenges I encounter when I doing the project is like the first one is how to define one collision. How to define one collision means how close they are. How close they are. And how close they are means the distance. Why? Someone will say the distance is not really hard to calculate, and distance is not hard to demonstrate, to visualize, but distance is really hard when the proportion is not really friendly. So you need to trial a lot of the data. You need to do a lot of trials to find the really proper distance to define a collision. If the distance is too large, they can easily click. They can easily click with each other, so they will change to different graph easily, and that is not what I want. And if the distance is really short, so they can hardly click with each other, and it's also not the effect that I want finally. So define a proper distance is really hard. You need to spend a lot of time to do the trial, but it didn't mentally hard. And this is the first challenge, and the second challenge I faced is the changes, how to count the collision. How to count collision is like, you need to think about something like the force is respectively, like I hurt you and you also hurt me. So this is the basic idea, or the basic abstract idea that I use to count the collision is I hit you means you hit me. The force is between each other. So now I'm going to show my project. I think it's time to show my project. And this is the data that I use. Yeah, and another challenge I want to mention is how to find a perfect, or it's not perfect, it's good, a good scenario, or the base case, the base data, I think, the base data, because you solve that the base data I use is from the spiral.txt, and I did a tiny changes to the moi.txt, and how to find that txt is also time consuming, because I try a lot of data and they cannot achieve what I want. So now I'm going to start showing my project. Damn, I don't know why I can't speak English really well. I have been a long time that I didn't speak English, so forgive me. Sorry. And Project0. So the first thing is I need to do is to compile this Java file. Yeah, everything goes well. Then let's show. Yeah, initially you can find that all of them are yellow and all of them are some, but you can see that one of them changing to white and another one changing to Jupiter. The white one is Venus, I think. And here you can see that they are counting the times of collision, and this is you can think about, I visualize it because I do a little bit change on the code. It's not only just print out the distance or the velocity or something other stuff. I also print out the times of collision they had. And it's not the times of collision, but it's kind of a reflected times of collision, because based on the different number, they will change into different stages. And you can see that it's already changing to Earth, and the collision is still becoming, and then the Earth changing will enter. And someone will see that the middle white one will never change. The reason that because I'm not a creator of the whole data system, But I think the reason that the middle one didn't change is just to stabilize the whole universal system. Yeah, because it's to stabilize the gravitational force between each other to make them, they will never flew out of the scale, flew away from the universe, to keep them inside the picture. And this is the job or the goal of the middle white one. And I have 8 stages, eight stages of one planet. Oh, it's passed really fast. Normally there should be a Death Star, and it's already passed. Maybe not too many people see that. And this is the Kevin. The Kevin has 0 velocity, but he can still move. The reason that he can still move is because of the gravitational force generated by the middle one and other stuff, the net force. So it's really complicated. And here's just two Kevin here. And I think the system is almost go to the end, I think, but it's still moving. Yeah, and another thing I need to mention is that the reason that why this is automatic generation of the picture, that you can see the input graph is always the sun, but it's changed during different stages under different circumstances based on the times of collation. So, and this is final stage and position and something other stuff. So, and I think this is the demo of my whole Project0 Goldpoint. And forgive me that I didn't clearly explain the whole or the what I think on this project, because it's really hard to illustrate, and I'm really tired, honestly. It's already 3 a.m. I'm really tired. I need to go to sleep. So, but that's it, and thanks for watching this video. And this is the first video that I upload to the YouTube, and hope you guys enjoy it, and see you maybe next time. Bye bye. See you.